Proofs of similar triangles. So let's take a look at proving similar triangles again. So remember that in order to determine any unknown measures, whether those are angles or sides, you need to show that the triangle is similar unless it explicitly tells you that in the question. So for part A, we're going to create a 5-line proof to prove that these two triangles are similar. And then we're going to use that information to solve for that missing side length of x. So remember, anytime you are trying to prove two triangles are similar, you have to start by introducing your triangles. So I'm going to start by saying for triangle ABC and triangle, and I have to be careful about the order of what I'm doing, okay? So I did ABC, so now I'm going to do DEC because I want to go in this right order for triangle ABC and DEC. So now I need to come up with 3 reasons why these triangles are similar. And remember, I can either do angle, 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 side, 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 or side, angle, side. So because I don't know the measurements of all of my sides, I'm not going to use side, side, side. That's not going to work for me. I also don't know 2 side lengths, so I'm not going to use side, angle, side for this one. So I have to show that they're similar using angle, angle, angle. So let's start by taking a look at these angles right here where the triangles join. So where it makes that X pattern. So because the angles are opposite from each other, then these angles are exactly the same. So I can say that angle C in this bigger triangle is equal to angle C in the little triangle because of the X pattern, or you can say opposite angles, whatever you would like to do, right? So some people will refer to that as the opposite angle theorem as well, okay? I'll accept either of those answers. And then we're going to take a look at how we can determine the other angles are going to be the same. Now we have to be careful because we have to look really carefully at the symbols on our triangle. So remember that these arrow or the chevrons show that these are parallel lines. And so because they're parallel lines, we can use either the F pattern, the Z pattern, or the C pattern to help us look for those angles that are the same or the angles that add up to 180. So if we use the Z pattern, and we draw a Z right here, then this tells us that the angles in the corners of the Z's are exactly the same. So angle A is now going to be the same as angle Z, or sorry, D, and that's because of the Z pattern. Remember that your letters that you're drawing using parallel lines can be in any direction. So I can draw a backwards Z, and show that the other 2 angles are going to be the same as well. So I can say that angle B is going to be equal to angle E. And that's also because of the Z pattern. So when you're telling me that the angles are equal, also give me the reason why those are equal as well. So now that we've shown that all 3 of those angles are equal on those triangles, now we can finish off our proof. So therefore, triangle ABC is similar to triangle DEC because of angle, angle, angle. So now because those triangles are similar, we can use what we know about the ratios of sides to find out this missing value for x. So I'm going to set up my proportion. So I know that side X is going to be in proportion to side ED. So X is over 3. And then I need to look at two other sides that I know. Well, I know in this larger triangle, this side BC, which is 6. And in this smaller triangle, I know CE, which is 4. So that's the proportion that I have created using my ratios of my sides. So now I'm going to use cross multiplication. So 4 times X is equal to 3 times 6. 3 times 6 is 18. And now I'm going to take and divide both sides by 4. So X is equal to 18 divided by 4, which is 4.5. And the unit, so what I'm measuring my side lengths in, is centimeters. So always include that unit with your final answer. Let's do one more example. So this is an example of a triangle embedded inside of a triangle. So if it helps you to sort of visualize it a little bit better, we have the smaller triangle up in the top. And we have the larger triangle on the outside. So those are the two triangles that we're using for this example. So let's start by introducing the triangles. So let's start with the smaller one. So triangle LMN. And triangle, I have to go in the same direction, LPQ. All right, so what do I know? Well, I know that both of these triangles share angle L. So angle L is equal to angle L because it's the same angle. And then I'm going to use what I know about parallel lines to help me find or prove that the other angles are the same. I can use the F pattern to show that angle P and angle M are exactly the same. So those two angles are the same. I can also use the F pattern if I draw it upside down on this side, that these two angles are the same as well. So now I'm going to put that into my proof. So I can say that angle M is equal to angle P, and that's because of the F pattern. I also know that angle N is equal to angle Q because of the F pattern again. So because I've shown that all three of these angles are the same in these two triangles, I can say with certainty that triangle LMN is similar to triangle LPQ, and I showed that by using angle, angle, angle. So again, now that I've shown that those two triangles are similar, I can use the information about the ratio of sides to look for this missing measurement X. So what do I know? I know that I'm looking for X, and the side that's in proportion to X would be 12. Now, what do I know about the other sides of my triangles? Well, I know that from L to M in my smaller triangle is 15 centimeters. I also know that from M to P is 5 centimeters. So the entire length of this side is 15 plus 5, which is 20. So the length of the larger side is 20. So now I'm going to use this information to solve for X. So I'm going to use cross multiplication. So 20 times X is equal to 12 times 15. So I have 20x is equal to 12 times 15, which is 180. And then from here, I'm going to divide both sides by 20 to get rid of that coefficient in front of my variable. So I'm left with x is equal to 9. And I look at my measurements. All my dimensions are, my lengths are being measured in centimeters. So x is equal to 9 centimeters. If you have any questions about this lesson, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.